Hi, my name is Amanda and I work at the Materials Science and Engineering Department at the University of Sheffield. I work with people who look at materials every day on how to make them better, stronger and more sustainable, like building a better battery or how to store nuclear waste more effectively. I also work with people who are looking at new materials and how to develop those. We're using inspirations from nature, things like spider silk and slime. In order to do all this wonderful work, they need to know how materials behave, and the best way of doing that is to test them. Now, material scientists really like to break things in order to test them, and that's what we're going to do today. We're going to do a couple of simple experiments to show us how materials behave. So you'll need a couple of things. You'll need some chocolate bars and you'll need some spaghetti and some lasagna. I've also got some linguine. If you're worried about things flying around like bits of spaghetti or lasagna, then perhaps get a pair of sunglasses that will protect your eyes. The test we're going to do is a bend test. This is a very simple test, but it tells us the tensile strength of a material. So that's how strong it is. We also do things like torsion testing, which is twisting, and that's different forces involved, but we're just going to do a bend test. So we're going to start with the spaghetti. The reason I picked spaghetti and lasagna is because they're all made out of the same thing, pasta. Pasta is effectively flour and water. So we're going to look at what happens when we try different types of pasta. So we're going to use the spaghetti, the linguine and the lasagna. Linguine, spaghetti and lasagna. And look what happens when we take the same material but do different things to it. So you have lots of different pasta types at home. You may have fusilli or penne, but these are the ones we're going to test. So we're going to take the different types of pasta and we're going to do a bend test. A bend test is when you hold it at the end and basically bend it upwards. Now you're going to estimate how strong things are before they break like that. So we're going to do it with the spaghetti first. That was a demonstration. So we're going to do it with the spaghetti first. So this is a full length of spaghetti. And we're going to take it on the end and we're going to bend. So this is going to bend quite a lot. So it's quite flexible, but it will get to a stage where it breaks. So the force that needs to break that will tell us what the tensile strength and how strong this material is. So just show you again, I'm going to bend it like that. So it's quite easy to break and it breaks into two pieces. So we can do that with a few other bits. So we'll just try it on this bit as well. So we'll try again, bend it and it breaks into two pieces. Next, the linguine. So this has got a different profile. This has got like a flat profile. It's as long as spaghetti, but it's a different process to make it like this. So we're going to bend this one and look, it's more flexible. It's taking more force to break it and it breaks there. Now there's a piece flung off somewhere and this breaks into three pieces. One here, one there, and one that's gone over there somewhere. So we'll just try that again. Bend it again, and it's going to bend, oh, and there we go. We've got our three pieces. So the spaghetti broke into two pieces. This one broke into three pieces. So it means it fractures differently, it breaks differently. So it's got different properties. The lasagna sheet, I'm going to break into half because this one's got there. So I've got two pieces, so I'll try. So again, now you might want to put sunglasses on for this one because the bits might fling off in different places. But we're going to bend this up. Now this one's a lot tougher and a lot harder to bend as much as the other ones did. Now I can hear it cracking, but it's not broken. And it's cracked a bit more. So I'll see if I can get closer so you can hear it. It's cracking, crack that, and there we go, into lots of different pieces. So still pasta, but breaking differently. So again, we'll try it with this one. And again, lots and lots and lots of force, and it's cracking and it's going to break. There we go. So lots of different pieces this broke into. Now my lasagna breaks into bits like this, but yours might break into more jagged pieces. So this demonstrates that it's got different properties to the linguine and the spaghetti. So now we're going to try the chocolate. So I've got 4 different types of chocolate. I've got a twirl, Kit Kat Chunky and normal Kit Kat, and a lime bar. So the reason I've picked these is a twirl's just made out of chocolate. The Kit Kat is chocolate with wafer inside of it. So I've got the normal size one and the chunky one. I'll show you why in a bit. And the lime bar has got chocolate, wafer and caramel in it. Material scientists often add things to materials to make them stronger. So we're going to look at what difference that makes to the bend test when we just look at chocolate with wafer and chocolate with caramel and wafer. So this will help us decide which one's the strongest. So we're going to start with the twirl, and this time the bend test is a little bit different. So the bend test is going to be a 3-point bend test. So we've got chocolate and we're going to put our fingers in the middle of it. So push down with these 2 outside onto that. So this is a room temperature twirl. So I'm just going to do it. Oh, there we go. So it's bent, it's broken quite easily, and it's a nice clean break. So that's what we're going to look at with the rest of them. So we're going to see if it's stronger than that. So now I'm going to do a Kit Kat. Now a Kit Kat is chocolate with wafer. So again, 3-point bend, push down with these 2 outside onto that. Oh, and there it breaks. Now that's an even cleaner break, but it was about the same to break those 2. So we're going to look at a Kit Kat Chunky instead. Lots of chocolate with lots of wafer inside, but there's also this little breakdown here. Now this introduces a stress point to it, so it means that it's a bit weaker there, so it means it should be easier to break like that, because that means it's a point for us to break it. So what I'm going to do, I'm going to turn it over. Now because this is flat, it should be harder to break, so that's what we're going to do now. So I'm going to just try it and see if it's really hard to break that way. There you go. That was really tough to break. So we've got wafer inside that toughens that compared to just chocolate inside the twirl. So by adding these layers of wafer inside makes this a stronger material. The last one we're going to do is a lime bar. Now a lime bar, because it's got wafer and caramel, should be even harder again. So more force, and it's going to be tougher to break. This is really difficult to break. There you go. So that one, now we can see, has got caramel inside, and that caramel has acted like a glue between those layers of wafer to keep it together a little bit longer. So that has made this material, this lime bar, even stronger. So 3 different types of chocolate breaking in very different ways, having 3 very different cross sections. So we've got the chocolate, I'll change these around, chocolate and wafer, chocolate, wafer and caramel. So that was the easiest to break. This was quite tough, but this was even tougher to do. And you should be able to feel that when you're breaking them. If you wanted to try something different, you could try what's called a torsion test, which is basically a twist. So I'm going to do that with a Kit Kat because we should be able to see this, how this breaks very differently. So I'm not going to do that way. I'm going to take these ends and I'm going to try and twist it. And by twisting it look completely different the way it breaks. And this shows us something different. This shows us how tough this material is when it's twisted. So that's a few things you can try. So the bend test, 3-point bend test, and the torsion test for you all to have a go at home and become material scientists and stay curious and try things and look up things and see what you can make out of the materials around you and how you can make them better and how you can make them stronger, because that's what material scientist does.